Okay, investigating graphs. So obviously this is a linear function. This is a quadratic function, two functions you're familiar with. And these are examples of a cubic function. Quartic, quintic, that means to the third power, to the fourth power, to the fifth power. And if you notice on these, a lot of times what you'll see with cubic is you'll have two loops, okay, or two curves, like a roller coaster. It goes down, comes back up, comes back down. So that would be two of them, right? And then with quartic, which is the fourth power, it's 1, 2, and 3. It'd be 3. And quintic, it'd be 1, 2, 3, and 4. Okay, so one less. So that would be the most. So quintic, the most it would be 4. Quartic, the most it would be 3. Cubic, the most it would be 2. You will see, a cubic function that looks like this that has one curve. Okay, but it won't have any more than 2. End behavior describes the values as x approaches infinity or negative infinity. So end behavior is what happens at the end of a graph. Okay, so if I have a quadratic function here, what's going on with these two arrows? We're going to talk about that right now. This, I recommend taking a screenshot of this or looking in the Google slide that I'll attach to Google Classroom. This is a good reference sheet to have. Okay, if you have your leading coefficient as positive, here my leading coefficient is 2, right there. That's not in order, right? 2 would be the first. And here my leading coefficient is 2. So the coefficient is positive, and if the degree is even, so the degree of this one right here is 2 plus 1 is 3, and the degree of this one is 2, 1, 0. So the degree of this one is 2. This one's 5, 1, 0. So the degree of this one is 5. So if it's an even degree, the end behavior is going to look like this. So the graph might look something like this, but then it goes back up. And this one, the end behavior looks like this. So we might go up and come back down, but then at the end it goes like that. Okay. Same with this. If the leading coefficient is negative and the degree is even, it'll go, maybe it'll go up, down, back up, back down, but then it'll go finish off going this way and this way. And vice versa for this one. Maybe we'll have something like that. So how would you say this? Let's look at this graph. Let's try to make this look kind of reasonable here. So if I have this graph here, something that looks like this, as x approaches infinity, so as x goes to the right, y approaches infinity because y is going up. So as x goes to the right, y is going up. And what about this one? As x approaches negative infinity, or to the left, y approaches negative infinity and goes down. Okay. This one right here, just like if we just had this kind of graph here, this parabola, as x approaches infinity, as x goes to the right, y approaches negative infinity. It goes down. As x approaches negative infinity, y approaches negative infinity. Okay. So let's look at this one first. We got a coefficient. Leading coefficient is -4. The degree is 3. So what's the end behavior? So we got a negative coefficient and an odd degree. Negative coefficient, degree odd. So my graph for that one would look something like this, maybe.